Hey everyone. So today I have a student from NYU. He's a sophomore. I think he's preparing for his interviews. Probably goes. NYU is a great school, so probably can get an interview at pretty much any company. So I guess at this point it's just making sure your lead code skills and interviewing skills are up to par. Can you quickly give a quick background on yourself, by the way? Maybe
Oh yeah,
just
yeah.
like what school you did. Maybe if you did any internships, how many lead code questions.
Yeah, so I'm third year at NYU, and I've done like I think like just under like 100 easies, and maybe like around there for mediums as well. But I mostly just started like beginning of this year. And then as for internships, I did one freshman year at like a semiconductor company, and
Mhm.
then one this past winter at just like a startup, and then this summer I'm gonna be at Square.
Nice. So no, you haven't done any hard questions.
Hards, not really. Like if there's like one or two interesting ones, I'll like look at it, but I haven't really tried to like do it
Cool,
myself yet.
cool. So your third year at NYU, right? That's in New York.
Yeah.
Okay. What companies are you targeting for maybe when you graduate or your next recruiting cycle?
Uh, um, I was thinking maybe some like fintechs or like unicorns. Um, like maybe shooting high for something like Stripe or like Airbnb or something. But
Nice.
yeah, I'm just trying to like get my lead code up. So
Okay, cool. So how are you with arrays?
I think I'm fine with the race.
Okay. Give yourself a rating out of 10.
Maybe like 7.5, 8.
Okay. Um, Link list.
Ooh, not really. Haven't been studying those, so probably like a 4 or 5.
Okay. Let me think. Trees.
Same thing. Yeah,
4 or 5.
haven't really looking
Okay.
those yet.
Graphs.
Same.
4 or 5.
I feel like I'm trying to
Oh yeah,
get
you're
back in.
trying to avoid trees and graphs. You know for sure they're not going to ask you trees and graphs because these are the most common questions that they ask trees and graphs.
Or no, yeah, like right now I'm just trying to because I'm like easing back into it. I'm gonna
I
like
see.
try to dive into that more, but focus on everything else first.
Okay, so you just want more of a raise. What have you practiced so far that I could ask you?
Uh, I've done a lot of like I guess like hash maps or like arrays or like things like that. Probably mostly arrays, but I haven't done it for a little bit. So
Okay. Um, Hash maps and arrays. Okay. All right. Okay, I'm gonna. I think that's all the information that I have. I'm gonna quickly pull up a question. Uh, All right. I got the first question. I'm gonna send you an invite. I'm
cool. Let me
gonna.
know.
I'll put in this chat right here.
Got it.
Cool. Nice. Yeah. Go ahead. So go ahead and read it and let me know what your thoughts are.
It's the valid palindrome, right?
Yeah.
Cool. Cool. So we're given a string s, and then we want to return true if it can be made into a palindrome after deleting at most one character. Okay, so looking at the test cases, s equals ABA, and we just return true because it's already a palindrome. ABCA, and then we also return true since deleting C gives us ABA. And then number three, ABC return false because we cannot make a palindrome. Okay. So I think my initial approach to this might be like taking a similar direction as the original problem where we use like a two pointer, but this time maybe if we run into like a disconnect, we can like try to skip that character, and
Hmm.
then if we run into the same problem again, then we just return false.
Okay.
Um, let's try that. So let's set left and right as the indexes of like the last and the first.
Hmm.
Also, first of all, if s length is one, we can just return. Uh, so if length of s is one, we just return true.
We can't.
Otherwise,
Your typing is louder than your voice for some reason. I don't
Oh,
know.
really?
Maybe.
Hold up. Is this better?
Let's see. Type.
Wait, I have a keyboard on top of my laptop. One second.
Okay.
Yeah, so left right equals
Yeah.
0, and then let's
That's
make
better.
the
Yeah, for sure.
all right, cool. So let's make the like 2 pointers to the beginning and end of the string,
Sure.
and then what we want to do is maybe like try to keep iterating to the 2 pointer until I guess the left, while the left is still smaller than the right, and then we do let's check if the characters at each pointer are the same. So if s left equals s right, we can just so left plus equals 1, right minus equals 1. Otherwise, what we want to do is maybe at this point we would have to choose between either skipping the left or right, and since we don't have access to like the rest of the string, we are not sure what to do. So we could maybe return like something where we have both the left and like check the left and the right. Maybe we could use like a helper of some sort, and then return something like valid helper string the left plus 1 and right, and or valid helper string left right minus 1. And then for that we can just throw that in here. Or we don't have to pass in the string then. But with that, it would just be like the same thing, I guess. Like while I less than, or while left less than right, we just do if s left is not equal s right, then we just return false. Otherwise, we increment them. And what this should do is like when it hits like two different characters, it like returns true if like either skipping the left or the right one gives us the right answer. So let me try to run this. Oh, maybe no. Oh, if we skip through this, we just return true. ABCA return null. Oh, oops, I have to put it here too. My bad. Okay, looks like that worked. I can try submitting it.
Nice. Is there any way to clean up the code a little bit?
Some code, yeah. Let me see. We could just like have it outside of the main function too, but let me do this actually. This doesn't change anything, but I'm not sure if there's like a better way to solve this. But I think like in either case, you would have to check like both the cases, like skipping left or right.
Yeah. So why do you have to check both cases?
Since you don't know like at that index like whether the left or like the right is the one that's the odd like character out.
I see. Yeah. Okay, that makes sense. Yeah. Code's working. Good job. Pretty fast on that question. Let's move on to the next question. Could you leave this question?
Yeah. Okay.
Just end it. Yeah. Okay, I'm gonna send you the next one. Nice, Sharon. Okay, yeah. I'll let you go ahead and read that.
Cool, yeah. So we are given an array asteroids of integers representing asteroids in a row. So the indices of each asteroid represent their relative position.
Yep.
And then their absolute value. So the value of the element represents its size, the sign represents its direction, positive meaning right, negative meaning left, and they all move at the same speed. So we want to find out the state of the asteroids after all collisions. If two meet, the smaller one will explode, and if they're the same size, both will explode. And then two asteroids moving in the same direction will never meet. Okay, let me see. So for the first example, we have 5, 10, -5. So let me see. Okay, so that means the 5 and 10 would be moving in the same direction. So they never collide. And then the 10 and -5 collide. And then since the 10 is greater, it's magnitude, right? So it would just result in the 10 staying. And then 8 and -8, they never, they do collide, but since they're the same magnitude, they both are removed. And then finally, the 10 and 2 don't collide, but the 2 and -5 collide, resulting in -5, and then the 10 and -5 collide, resulting in 10. Okay. Um, so, since we have to like still like maintain, I guess, like information regarding like every element, even if like the the elements that like the indexes next to it like don't interact. Like let's say 10 and 2, since they don't collide, we still have to maintain like information about 10 since down the line like it could collide with something like -5, right? So to do that, maybe we could use something like a stack, maybe. Um, and then uh, mm, maybe have it so like while the like top of the stack is the same like um direction as the next asteroid, we like just append it to the stack. And then otherwise, once it is not, say like we have 10 and then we add 2 to it. Once we get -5, we deal with that interaction then. So let's
Okay.
try that. So for asteroid and asteroids, let's do while mm, while asteroid um, mm, we can do like if stack and stack -1. Okay, so we have to check if they're the same like parity, but to do that, Loki, I'm blanking. Well, we can just check like for positives for now. So like, or for negatives. So maybe like while stack, like, let's say we run to a negative, and so while it's valid and the asteroid is less than 0. So let's say we have like -5, and then like let's say we have a positive, so that means the last index would be greater than 0. So while like the next asteroid is negative and the stack is like the top of the stack is positive, we want to check if the um like the the magnitude of it's greater. So if stack -1, so if the one existing is smaller than the current one, then we can just pop. So stack.pop. And then otherwise, like if it is greater, So let's say like here, right? So it's -10, -5. Since 10 is greater, or like the last one in the stack is greater, we just disregard the current like asteroid. So we just continue, I guess. And then okay, so what if we start with a negative though? So if we get -5 in here, like the first one's -5, we skip this since it doesn't exist. We would just, let's try that first. So stack dot append asteroid. Let's look at the first test case. So 5, if we get 5 in here, we just append it. And then next one, since 5 is not less than 0, we just append it again. And then if we get -5, we go here. And since asteroid is less than 0 and also less than 10, we check this. And since it is not greater in magnitude, we don't pop it. And then, okay, never mind. We don't do this. We don't append it. We only append it if it is
Maybe easier if we actually write it down, like simulate the stack. Right.
Yeah.
Just walk me through now. Okay, you're gonna put 5 in there.
Okay.
And then yeah, just dry run it now.
So we put 5, and then that stack would get we'd have 5, and then once we run into 10, same thing. Since it doesn't go through this while loop, we also append 10.
Sure.
And then when we get -5, we do enter this while loop, but since it is
like why do we enter the while loop?
Since asteroid is less than
Less than
0
0.
and less than like 10.
But is 0 okay? 0 is greater. Like the condition is a bit weird. It's like asteroid is less than 0 and less than 10. Okay. I see. Okay.
Let me check. Since if it's like not negative, so like if we're only holding positives, right?
Yeah.
If it is not negative, then we can just append it directly here.
Yeah. Okay.
Otherwise, if it is negative, we want to check if it is greater than the like top of the stack. And while it is greater, so let's say we have like 15, like -15, right? Then this would pop 10 and then pop 5.
Yeah.
But I'm kind of messing with this because, like, let me see. Let me just try to make it work for like positives first. So like only showing positives. So if it's less than asteroid, then we pop. And then oh, let's also check. So in this case, it's like breaks asteroid like on top of stack. Otherwise, like if it's the same, so same as asteroid, then instead of like continuing to iterate through, we would just pop it, and then we would break the while loop since the like negative asteroid also like explodes.
Okay.
Oh no, this is only if it's like equal. So L if asteroid or negative asteroid equals stack -1. Okay.
Okay.
And then I think that should work. Let me give it a run and see what happens.
Let's do a dry run. Like don't run the code yet.
Okay.
Right. Let's do a dry run.
Yeah.
Let's start empty here and then dry run me through how this is gonna work for this example. Right here.
Cool. Yeah. So first we have 5, and we just skip this since stack is empty, and then we append it. So stack becomes 5, and then when we have 10, we do go into this part since like stack exists, but since the asteroid is greater than 0, it's positive. We just break out of the while loop and then have 10. And then now that we have -5, right? So now that we have -5, this condition is met, And then since neither of these conditions meet, we just should um like break out of this while loop. Oh, we shouldn't add this. So we'll just do else, meaning that it is we should just continue. I think we should just skip like appending it. Like -5, we should just move on to the next asteroid, since like it doesn't affect any of the ones currently in the stack.
Okay. Well, we're still gonna append it here, right?
Oh yeah. Or doesn't this continue like skip to the next one? Like the next.
Well, it's the continues within this while loop.
Oh right, right. Okay. Else and then we can just hmm.
So, which one are we looking at right now? Like, what's the issue?
uh I don't think this works either, since what we want to do is like if it is like if it breaks the asteroid on the top of the stack, we should just like um so what this does is like if the asteroid is greater, we pop the top of the stack and then we continue to the like we continue until it is
That makes sense. Yeah.
okay. And for this one, what we do is if it's the same, we pop the top of the stack, but then we break since we don't want to consider the rest like compared to the rest.
Sure.
And then otherwise, like the third case is if smaller than asteroid at top of stack, then we just ignore it. So we can just like break out of this, I guess, and
Sure.
then we can just like move this. Um,
Like, what's the main issue now? We're just adding the asteroid. Asteroid is even though we shouldn't.
yeah, we shouldn't add this. So maybe we should move this like up to break top, else pop break. Um, so we only append it if like this case like is the last one.
Yeah.
I'm kind of blanking out. Like, is there a way we can just like break out of this whole thing?
Okay.
Otherwise,
Bring back that line of code that you had.
yeah.
Okay. So, like, when do we have to do this? When do we want
So
to?
we only do this if it like breaks the asteroid at the top of the stack and like where it's like all cases besides these two cases. Like besides when it's the same since it disappears, or if it's like smaller so that it disappears as well. Like otherwise, we continue doing this until like either the stack is empty um or like
Yeah. What about we just break it until pretend we have an asteroid right here, like negative
mhm.
five. Like we have -5, right? We just break it while it's strictly less than, or we break it while it's strictly greater than, like, the absolute value is strictly greater than the thing that's greater than the stack. But if it's equal, then we stop and then we handle that case after. So we kind
Right.
of put, yeah.
So we just keep breaking it until like
Till we're less than or equal to, right? We break it till, so basically when we get here, we're less than or equal to, like, the absolute value. Is less
okay, yeah,
than
that makes
or,
sense.
yeah. Okay, I'll let you go from there.
Let me check this logic. So while stack and while this is here, the first thing is, yeah, if it's like this, we just pop. Else, if it's like this, we just or we don't need a. Oh wait, no, we do need a pop. So we break, and then else we pop, and then otherwise we just append, right? Like outside of here.
But let's break this into two sections, like, pop out of stack all values less than
Mm-hmm.
absolute value less than.
Mm-hmm.
Pop out of stack all asteroids that will get destroyed, right? Handle that case first. Like, simplify this code a bit.
Oh right, like if we don't do these cases, we won't even need to like append it. I mean, sorry. Like if we do this case, like if this case succeeds, we like don't need to append it. So we can just write like an else like statement outside of the loop, right? So like while this, if like this condition is not met, then we append it. Otherwise, we can just pop or like break or anything. So the first thing is we check if it's like if we have to consider destroying like anything within that string, and if not, so like example, if it's like positive or whatever, we can just go ahead and append it. So we can just do like else stack dot append asteroid, right?
What is this else on?
It's like if this while loop is not like the conditions aren't met.
Okay, but there's no if statement that goes with the.
Oh, I'm pretty sure like while like also has an else. Like if this is not met, it treats it as like an if statement.
Let me see. Is that
Can I try
is
to run
that,
it?
is that how it works? Oh, I didn't know that.
I'm pretty sure. Like I think I've used that before. Okay, let me see. So 5, 5, 10, 10, 5. Okay, so we're appending it incorrectly. Mm, okay, so I think it's working because it is appending it. Oh wait, we're doing it twice. Delete this. Let me write if conditions not met. So like we don't need to like worry about destroying. Then we append asteroid. Because like if it is less than 0, so if it's like a negative, then we have to worry about like breaking it. Otherwise, we can just append it, I believe. Like for example, if it's like empty or it like doesn't fulfill this condition. Let me try and run that.
Nice.
Okay, it looks like it works for
Nice.
this. Let me just go through one more time. So 5, 10, 15. If it's negative 15, we go into this. Otherwise, we just append 5 and 10. Yeah, I'm pretty sure like while loops, like if it doesn't,
Yeah.
it like treats it as like an if, but
Yeah, I didn't know that on Python. Interesting.
can I try submitting it?
Yeah. Yeah, it works. It works. It's good.
Okay, cool.
Yeah. Cool.
Yeah, this should just be like constant for both. I mean, not constant, linear. Linear to like the amount of asteroids.
Okay, yeah. Walk me through the time and space complexity.
Yeah, space, it should just be um, like if they, like none of them are destroyed, it would just be like mx, like the size of, or like the number of asteroids, so it would be linear to like the length of the asteroids array. And then time, uh, I believe it would just be the same thing because we're doing one pass.
Yeah. Okay, cool. All right, let's move on to. I think we got time for one more question.
Okay, sounds good.
You exit out of this.
Yeah.
And I'm gonna send it to you.
Cool. Okay. Let me try this. Oh, I think I've done this problem before.
Oh, you've done this?
Yeah, I believe so.
Okay. Um, let's see. Yeah, don't really have much any more questions. I think we could just probably end that there. You're just continuing to practice, right? So we could schedule another one. I could, because I can't really ask you any of the DFS or graph or tree one. So I
Oh, I
think
can try like the DFS maybe like it's like more BFS that I'm kind of stuck on, but like um or like
okay.
a matrix question or something maybe.
Let's see. Um, let's see. Let me grab the question.
That sounds good.
Okay, I'm gonna send you this next question.
Cool.
Oh shoot.
Okay.
Oh, I invited you to sing. Oh, okay. Okay, sounds good. Have you done this one?
I don't think so.
Okay.
Let me check.
Yeah, have a read at it and let's just work through it.
Okay, so given an integer array nums sorted in non-decreasing order,
Mm-hmm.
okay, so it's sorted, and then we want to remove duplicates in place such that each unique element appears only once, and then the relative order should be kept the same, and then we just want to return the number of unique elements. Wait, so we want to modify it in place, and then also um, return the number of unique elements. Okay, so consider the number unique elements in nums to be k, and we need to do the things following that are we need to change the array so the first k elements contain the unique elements, and then the remaining are not important. Okay, so let's look at example 1, 1, 1, 2. We would output 2, so that's the number of unique, um and then I guess like the last one like can be any number. And then for
Mm-hmm.
example 2, same thing, we just move the unique ones to the front, and then the rest do not matter. Okay. Um okay. I think what you can do here, I think I remember like doing something maybe kind of similar like a while ago, but like I believe it's something where you use a like you store the counts of like either like unique numbers or repeated numbers. I'm pretty sure it's like maybe it's like repeated numbers, and then since we know it's like sorted, as you get a number that is unique, you swap like positions until everything is like until you iterate through the whole array. So like all the unique ones are in the front, and then the rest should just be it would just be like whatever you swapped it with. Um, I don't remember exactly how to implement that. We can try.
Wait, let's see. I don't. I'm not quite following what you're saying. Could you probably list it
I'm
out?
not sure if it's like a similar question, but like something where let's say you have like 1, 1, 1, 1, like 2, 3, or okay, let's shorten that actually. As you like iterate through, so let's say you see 1, right?
Hmm.
You like keep it there since it's unique. So maybe we can like have a set or some shit, and then like when we see one that like is repeated, so it's already in there, we just like increment like a counter. Like let's say we see this, so counter would be 1, and as you see this, it would be like 2, and then when we see a new one, like a unique one, we just swap the value here with the index at like the current index minus like the amount of repeated ones. So we just swap 2 to like here maybe, and then when we get 3, it's another unique one, so count is still 2, and then we swap it to like here, etc., etc.
Wait. Okay. I mean,
We always like maintain like
you're
that's where we're inserting like the new ones into.
so you have a count. So we have a pointer here. We have count
Right.
goes. Count equals starts at 0. Can you dry run me
Yep.
on that?
Yeah,
Again?
we count starts at 0, and then like
Good.
when we see one that like we've already seen before, we like don't do anything, but we like increment it to 1, and then when we see another one, we increment it to 2, and then when we see a unique one, so like 2 here, we just swap like the values at the current index and the current index minus like count.
Okay.
So -1, -2, 2 would be swapped here.
Okay. Swap. So this becomes 1.
Or it doesn't need a swap, but like I don't think swap matters because we like don't use this. Like this is gonna be overwritten.
Yeah.
Since we have like basically count is gonna like I minus count would be the like index that we insert the next unique element at.
Okay.
Since we don't care about like everything following the first K, like I don't think we need to swap it. We just need to make the one that is like I minus count into the, and like when we see 3, since count doesn't increment, since we don't see a like repeated one yet, we would just do the same thing. So I minus 2, so 3 would go here. And then let's say we have like another 3 and then 3 and like a 4. Count here would be 3 and then it would be 4. So we take 4 and then go 1, 2, 3, 4, and it would be swapped to here. And then the rest would just be whatever.
Okay.
Let me try to do that.
Yeah, go ahead and try to implement that.
So for I in range len nums, let's have a counter. So count equals 0. To store, I mean, we could use a set, I guess. Let's see equals set. And while like okay, if nums I not in scene, then we just do so if it's not in scene, then we just continue. So let's do it. So if it's in scene, so like we've seen it before, we increment count plus equals 1, and then otherwise we want to make it the index like I minus count. So we do nums I minus count equals nums I. Let me see if that works. So let's say we have like 1. Oh yeah, we have to add it to scene, but so we see 1, and then we just add it to scene, and then 2, same thing, 3, same thing. Oh, oops. And then 3 again. Here we would just increment count again. So count would be 3, and then 4 we would just take I minus 3, which is here, equals nums I, and then add it to scene, and then return or no, we don't have to, we have to return K.
Okay,
So return,
is this complaining about one thing? Oh yeah,
so was
return
that?
K. It's complaining. Oh, okay, I guess it didn't look at the other ones. Well, I thought it wanted to swap, but yeah.
Uh-huh.
Um, so what's your time and space complexity here?
Space would just be like, I mean, worst case, it would just be like they're all the same. So it would just be or I mean, they're all unique. So the max like size of the set would just be the length of nums, and then time it would just be we're just doing one pass through, so linear as well.
Okay,
The
so
number of elements.
I'll ask you this. So it's an OVAN space, right?
Mm-hmm.
How could we get it down to OV1?
All right, we probably don't need a set. Since it's sorted, um, we could maybe do something like check if it's like greater. Let me see how we would do that. 1, 2, 3, 3. So we have 1 and 2, 3. So instead of like checking if it's unique, we can just check if it's like greater than the previous element. Let me see if that makes sense. So if nums I, so if I greater than 0 and nums I, oh no, this is checking if we've seen it. So if nums I, so if I greater than 0 and nums I equals nums I minus 1, that means, okay, so like repeated. Else, So if it's unique, I guess it's not like equal to the previous one. But in that case, yeah, wait, let me see if that works. Uh, and then we would just return something like length of nums minus count maybe. So what this is doing is it's like checking if it's like repeated, because if it's like greater than 0, so like starting from the first one, if it's like equal to the previous element, then we know it's like a repeated, and then otherwise if it's not repeated, we just swap. I mean, not swap, like overwrite.
Yeah. Cool. Nice. Yeah. Worked. How do you think you did?
Uh oh, like the
Interview.
whole
Yeah.
like
I asked you three questions. Yeah.
mhm. I think I did fine on like the first and this one, but the second one, I guess like I haven't been too like doing too many questions with stacks, so I would need to like refresh on that like a bit too.
Nice. Cool. All right. Let me see my feedback. So yeah, first question easy. You solved it easy. Good job. No real notes from that. I think it's all pretty easy. Q2. Yeah. You. Let's look at question one actually. Question one. What you did well. You solved it pretty easy. I think you're good with the indices. People make mistakes on off by ones. Like maybe they access the end of the array.
Mhm.
Sometimes like they just mess up the indices sometimes, but you didn't really run into that. In this question, people get wrong sometimes of like the conditions of when we're gonna keep looping and stuff. When
Mhm.
you return true, they also get wrong that we need to try either deleting from the left or deleting from the right. But you caught that and cleaned it out. Have a clean solution. So overall, really good job. Second question, that's the one where you had more trouble with. I
Mhm.
think the asteroid collision. I think for that, my notes about that is just I think dry running it on the comments and then reasoning about it. I think you just could just be a little bit more strategic in catching the edge cases. I think
Mhm.
you knew exactly what to do, but all your if statements and stuff, it was you're churning a lot on it. Like you're had ideas, but you're going in circles a bit, trying to figure out the conditions here. So I think you could be more strategic with how you like break down the different cases, and how you could be more strategic is work through the different cases or be more methodical. So what are the different cases for the asteroids, right? If
Right,
it's
yeah.
equal, then what are you gonna do? If it's greater, then what's it gonna do, right? If
Yeah, I
it's
kind of
less
like
than,
yeah, that one I messed up because like I kind of had the idea of like what I wanted to do, but I should like planned it out like each case to like make sure I
yeah.
didn't like mess it up at any point. But
Yeah, I think, and the best, maybe the a good way to do that is simulating it and just having the notes we had here. I think helped with your thought process a bit because you could see it there. Of okay, we're dealing with -5. Like when we wrote down the notes of what the stack is gonna look like and how we're
mhm.
comparing the last value to what's on the stack and how we're like moving it out. So I would just write some notes down so you could visualize it because you're good though because you're able to visualize it in your head.
Mhm.
But if it was a more complicated question when you're visualizing in your head, you're gonna turn too much in the interview and you're gonna run out of time.
Right, yeah,
So
definitely.
getting things off into the notepad to see, okay, run it to a case and then and write it down what case you're looking at specifically helps both you and the interviewer visualize it. So
Right, yeah, that definitely makes sense. Like even before you, I guess, like finalize your solution, just like having a separate section where you can like see how each part of like visualize what each part of your code does. Like that's definitely gonna like make things easier for like yourself too.
like I think
And
here, yeah,
probably
when we visualized it, you were seeing, oh, we just -4 and then you're swapping. I think
mhm.
imagine you just had to keep that in your head the whole time and there's a small logic error.
Yeah,
I
for
think
sure.
it's like yeah. But overall, really good. Ramp up on the trees and grass, and we'll test you there because those are the ones that are really you really get asked. This is you're really good though, honestly. Um, for the questions I
Yeah.
did, like pretty much no feedback. I think we solved 3 questions in 45 minutes, so yeah, we'll just keep up the training and just hit me up whenever you're gonna when you want to do more of the trees and grass. I think yeah, that's when we'll see where you're at because arrays, yeah, you're already good at. So I wouldn't be too worried about that.
Yeah, thank you. Sounds good. Yeah, I'll definitely like review those in the
Cool.
future.
All right. Thanks for coming out. Talk to you later.
Well, thank you so
See
much.
ya.
Bye bye.
No problem. Yo, chat. How do you think he did? Okay, I'm gonna get the next person on. I just need my water. Every time I hop into Google Meets, it tweaks. Jay, what's up?
Hey,
How you doing?
hey, James, congrats on 50K and congrats on Meta.
Thanks, man. I appreciate it. Thanks for hopping on again. I remember we did one way back.
Oh yeah,
Did we do
yeah,
it on
that was.
stream? Like you
I
hopped
mean,
on
I'm
stream?
still looking for a job. Yeah.
How long ago was that you we hopped on stream?